Okay, in this video we're going to look at cast diagrams. Now we're going to skip through a bit of these notes here. There's a lot of notes, and it's probably easier once we get on to the examples to explain it. But if we look at our three trig functions, that's sine, cos, and tan, and we just look here, and this is us going from 0, and it's funny you go around the anti-clockwise way, 0, 90 degrees, 180, 270, and 360. In this first section, so from 0 degrees to 90 degrees, sine is positive, cos is positive, and tan is positive. So all three are positive. So this is the A section, which stands for all. Now, if you then go from 90 degrees to 180 degrees, and say pick an angle in between 90 and 180, so I'm going to pick 150. If you did sine of 150 in your calculator and pressed equals, it will give you a positive number. If you did tan of 150 on your calculator and pressed equals, it will give you a negative number. And if you did cos of 150 and pressed equals, it would give you a negative number. So this is the S section. It's called S because sine is positive. Okay, this one is the T section, and that's because tan is positive. So if you pick say we'll pick 210, tan of 210 would be positive, sine of 210 would be negative, and cos of 210 would be positive, or cos of 210 would be negative. So only tan is positive in this section. And lastly, from here, so say we pick 330, cos of 330 would be positive, sine of 330 would be negative, and tan of 330 would be negative. So only the cos is positive. So it's called a cast diagram, C-A-S-T. So if you start in the bottom right hand corner, C, then A, then S, then T. Okay, we're going to look just a couple different ways we could have labeled this diagram. So on this one, if you notice, we're going 0, and if you want to go back, if you want to go back to minus 90, you're going clockwise to get to minus 90. So again here, it's the same thing, cos. So if you did like cos of minus 45, it would be positive. Sine of minus 45 and tan of minus 45 would be negative. So it's still C here. Likewise, only the tan would be positive in here. So between minus 90 and minus 180, tan would be positive, the other two would be negative. Now here, so between minus 180 and minus 270, sine would be positive only. The other two would be negative. But in between minus 270 and minus 360, all three of them are positive. So cos is positive, sine is positive, and tan is positive. Okay, one more way to look at these. Okay, this is a very common way for them to ask you. They ask you to solve these equations on the range minus 180 to positive 180. So 0, 90, 180. Going anti-clockwise, then 0, minus 90, minus 180. And again, we've gone through these top two when we looked at our first graph, and where at the top right, it's A, all are positive. Top left, it's S, because sine are positive. And then in our next graph we looked at, next set of axes, the bottom right, cos was positive, and bottom left, tan was positive. So it still obeys the same rules. C-A-S-T, so cast diagram. And the C tells you what's positive, the A tells you all are positive, the S tells you what's positive, and the T tells you what's positive. And that's it. Okay, we're going to go on and look at a couple of examples on how we actually use this to solve questions. Okay, before we use our cast diagram, we can look at this. We'll just want to look at this one. It says solve sine x equals 1 for 0 to 360 degrees. So it says here you can examine the graph of sine to minus y equals sine x in the valid range and simply read off the values which will solve the equation. Okay, and if you read that off, you will see that, oops, sorry, I'm the wrong color here. If you read off the values, you will see that sine x equals 1 when x is equal to 90 degrees. Okay, now this is very important, folks, and worth your while learning that sine x is equal to 1 at 90 degrees. Where 1 is on your cast diagram, where 90 degrees is in your cast diagram would be here. So pointing vertically upwards would be 90 degrees, and that sine was equal to 1 at that position. That means in the other position, so down here, sine would be equal to minus 1. So, and if you think about what angle that would represent down here, that would either be 270 degrees or minus 90 degrees. And sure enough, if you look back at your original sine graph, sine is equal to 1 at 270 degrees and also at minus 90 degrees. And that's very, very useful. Another thing which is useful for you to know is that you know from your graph, this pen is playing up, sorry, that sine x, you know from your graph that sine x is equal to 0 when x equals 0. Now let's look at our cast diagram. 0 is over here, so sine x equals 0 over here. It's also going to be equal to 0 in the opposite place. So over here, it's going to be equal to 0. And what this represents over here would be either 180 degrees or minus 180 degrees. So sine x equals 0 when x equals 0, or over here, x equals minus 180 or minus or positive 180. Okay, we're going to look at a better example here using our cast diagrams to solve trig equations. Okay, I've skipped out a wee bit of notes here on how we do this. We're just going to talk through it. I think it would be better use of our time here. So it says solve sine x equals 0.8 for 0 degrees is less than or equal to x is less than 360 degrees. Give your answer to 3 sig figs. So the first thing you need to do is find your basic angle. Okay, so your basic angle, and so basic angle equals, and we're going to abbreviate that to BA. So in future, I'm just going to be saying basic angle, but I'll be writing down BA. How you get your basic angle is, well, I got 53.1 degrees, but what I did, how I got that was just sine to the minus 1 of 0.8. So that's where I have got that from. So on my calculator, sine to the minus 1 of 0.8, and that's 53.1 degrees. Okay, so 53.1 is what I want to do. Next step, what you want to do is you want to draw your cast diagram as we have been referring to it. So your cast diagram, don't bother using a ruler. As you can see, I'm clearly not. C, A, S, and T. So remember, you start with a C in the bottom right and then work anti-clockwise to spell out the word cast. And then you look back at your original thing. Now, our thing here, our sine was equal to positive 0.8. So because now this is where this comes into play, that this was positive 0.8. And sine is positive in this first quadrant, so up here, and sine is positive in the second quadrant. So then you mark in your basic angle, and very important, it says this in your notes, you always mark in your basic angle with the horizontal line, so your horizontal axis. So your horizontal axis is here, your angle appears in here and here, so your 53.1 is in this bit and in this bit. Okay, I don't normally do this, to be quite honest, but for the sake of it today, I am going to label my axes. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and back to 360 degrees. Okay, now if I have a wee look at this, to find my first angle, I start at my 0 and I go round to get to here. So my first angle is going to be equal to, my first angle I'm going to come to is going to be x is equal to 53.1 degrees. My second angle, apologies, my second angle I come to is going to be is going to be all the way around to this one. So if you look at this one, it is 180 degrees. It's not quite 180 degrees. It's 53.1 degrees short of being 180 degrees. So if this thing will let me get another pen, and my second angle is x is equal to 180 minus a 53.1. So x is equal to 126.9 degrees. So I'll just write down my answer. X is equal to 53.1 degrees, or 126.9 degrees. Okay, and just noticing here, they've said give my answers to 3 sig figs. so which is equal to 53.1 degrees and 127 degrees, and they're both now to 3 sig figs. Okay, I'm just going to stop there and I'm going to put a wee note on this. I go through this once more on this particular example. Okay, so the wee note I've just added in here was just note that sine x was positive 0.8, so the angle goes in the S and A quadrants, i.e. where the sine is positive, and that's it. Okay, we're going to look at a few more examples in this. I know this is a very different looking thing, seeing this, so we'll do another couple of these just to make sure we really understand it. Okay, this example says solve cos x is equal to minus 0.0432, giving your answers to 1 decimal place. So in this one, we're going to say BA. I'm not going to write it down, but BA, remember, stands for basic angle. And how I've got this basic angle, this is very important. It is cos to the minus 1 of 0.432. So I ignore this minus sign at this stage. It will come into play later on. So if you do cos to the minus 1 of 0.432, you will get 64.4 degrees. Okay, so I'll just say here what I've done. I said, notice I ignored the negative at this stage. Okay, so that will come into play later on. Okay, your next step to do is draw your cast diagram just as before, C, A, S, T, and for your benefit, I wouldn't normally do this. I'm going to mark on my, label my axes, so 0, 90, 180 degrees, 270, and 360. And here, this is where the negative comes into play. So cos at the start was equal to negative 0.0432, and cos is negative in the S quadrant and in the T quadrant. So instead of going in the C and the A where cos is positive, it goes in the S and T where cos is negative. And your basic angle, remember, always goes with the horizontal, so that's 64.4 and 64.4, and then we have to do this. So I'm going to do this in red. I'll do both my arrows in red this time. So I'm starting at 0. The first one is all the way around to here, which is going to be 64.4 short of 180, and the next one is going to be all the way around to here, which is 64.4 greater than 180. So we will get back to our blue and give our two answers. So my answers, x is going to be equal to, the first one's going to be 180 minus the 64.4 degrees, or it's going to be 180 plus the 64.4 degrees. So if you do that out, what you're going to get is going to be 115.6 degrees and 244.4 degrees. And that's it. Okay, I'm just going to put an extra wee note on this, just like I did in the last one. I'll just pause the video and write that in. Okay, so the wee note I've put on, I said note, the angles were in the S and T quadrants as the cos x was negative. Alright, just one more thing to say on this, folks. If I was doing this myself in exam, I wouldn't be writing this in. This is just for the benefit of our notes, and I wouldn't be writing this in. I would just be doing basic angle equals, and I would do my cast diagram, and then I'd be writing down my two angles. So it really is very, very quick to do these questions if you do them well. Okay, last example before we're on to the next exercise. This one says solve tan x is equal to 5 for minus 180 to plus 180. So it says give your answers to 2 decimal places this time. Hopefully I've done that in my answer. So basic angle first of all, and how you get your basic angle is tan to the minus 1 of 5. I'll just write that in this time. Tan to the minus 1 of 5, and then hit equals, and you get, I got 78.69 degrees. Do your cast diagram. There's a wee arrow pointing there. It says watch for the inequalities. So just be careful in this one. So label your axes 0, 90, 180, and then going the other way, it's going to be minus 90, and it's also going to be minus 180. Okay, tan x is equal to 5. It's positive, So tan is positive in here or in here. So you draw your basic angle with the horizontal, of course. And then you're good to go with your angles. So I'm just going to write down x equals, and my two angles, my first one is going to be, I'll draw my red arrows on to show where this comes from. So going from here, my first angle is going to be 78.69, and doing the other one, it's in the negative thing, so you have to go back the way. So it's not quite back as far as minus 180, it's minus of 180 minus 78.69. So I'll show a wee bit of working out for doing these ones. All sorts of weird and wonderful ways of doing these. As long as you're getting them right, just check it a couple of times, make sure you're getting them right. Oh. Right, bear with me, sorry. Right, here we go. So my first angle was easy, it was 78.69. The next one, and a wee bit of working out needed, it was minus of 180 minus 78.69, which works, so x is equal to 78.69 degrees, and the other one is going to be minus of 101.31 degrees. There you have it, there you have your two answers. Okay folks, you're now ready to do exercise 4b, questions 1 to 6, and exercise 4c, questions 1 to 6. The only difference in these questions, the first exercise, exercise 4b, I think the ranges are all from 0 to 360, whereas in 4c they're from, like this example, minus 180 to positive 180. But you're good to go with those now.